Hello friends, today's topic is Clausius inequality. Okay, so Clausius inequality say that uh, cyclic integration of del q by t less than equal to 0, less than equal to 0. That means this is very important formula. You have to remember this formula. Okay, so cyclic integration of del q by t is the absolute temperature. Okay, q is the amount of heat. Okay, so cyclic integration of del q by t less than equal to 0. Now this Clausius inequality is applicable only more than two reservoir or variable temperature reservoir. Okay, so it is applicable for more than two reservoir. You have to remember this. Now here here uh, for irreversible process, cyclic integral of del q by t less than 0 for irreversible process, and if the cyclic integral of del q by t that is equal to 0, then you can say that it is for reversible process. Okay, so this is for reversible process. Okay, so let's try to prove this equation here. Let's try to prove this. Okay, now case 1 is that there is a reversible engine, or consider it is a reversible cycle. Now for reversible cycle there is a engine is there. This is a engine here, and this engine is in between. There is temperature T1 and T2. This is source and this is sink. Okay, so basically the source temperature is T1 and the sink temperature, that is T2. Okay, that sink temperature is T2. Now here the amount of heat Q1 is amount of heat is transfer from T1 temperature source to the engine, and the amount of heat Q2 is transfer from engine to the sink. Sink means the temperature of the sink, that is T2, and there is some amount of work which is produced from this engine. Consider this is W1. This is W1, and consider this is a reversible process. This is a reversible process. Now if you apply this formula for reversible process, you know that this formula. So here this formula, that is cyclic integral of del q by t that is equal to 0. So here this is for reversible process, uh, del q by t that is equal to 0. From here you can say that integration of del q by t for reversible process, that is equal to, so here in that cycle, focus on this cycle. So in this cycle there is a engine, there is a q1 is entering into the system and q2 is outgoing from this system. So here, so that is why as q2 is entering to the system, so this is q1 by t1. Okay, temperature T1 is T1 the temperature of the source. This is the absolute temperature, and Q2 is outgoing from the engine to the sink. So that is why Q2 by there is a sink temperature which is in absolute. Okay, so there is a minus sign because the Q2 is outgoing from the system. So that is why there is a minus sign. Okay, now now for reversible cycle, we know that q1 by q2 that is equal to t1 by t2. Okay, if you rearrange this, you can get that is q1 by t1 minus q2 by t2 that is equal to 0. So put this value in that equation. You can get here you can get cyclic integral del q by d for reversible process, that is equal to 0. So from here you prove that that the cyclic integration of del q by d that is equal to 0 for reversible process. Now let's try to prove for irreversible engine. Okay, so this is case 2 here. Consider this is an irreversible engine. So here focus on this. Here consider there is a this is a source which has temperature T1, that is consider this is T1. T1 is greater than T2. Okay, T2 is the here T2 is the sink temperature. Okay, there is a sink temperature, that is T2. Okay, so T2 here, T2 is the sink temperature. So in between two reservoir there is a engine 1. So this is basically engine 1. This engine a reversible engine. This is a reversible engine. Consider this is a reversible engine. So this is basically absorb the Q1 amount of heat from the source and reject Q2 amount of heat to the sink and produce some W1 amount of work. So W1 amount of work. Okay, now in between two same reservoir there is another engine E2 which absorb Q1 amount of heat and reject Q2 dash. This is Q2 dash amount of heat rejected to the sink and produce W2 work. Okay, so one is a reversible engine and another is the irreversible engine. Okay, now from irreversible process, so here cyclic integral for irreversible process is del q by t, that is equal to, you can say that from here so here for irreversible process, so q1 is entering to the system, so plus of q1 by t1 and q2 is outgoing from the system, so that is why minus of q2 dash by t2 for this process. And for reversible process you can say that del q by t del q by t reversible, that is equal to 0. You prove that. So from here you can say that so here in this system so q1 is entering to the system and q2 is outgoing from the system. So from here you can say that plus of q1 by t1 minus q2 by t2, that is equal to 0. So from here you can say that q1 by t1, that is equal to q2 by t2. Okay, so this is equation number 2 and this is equation number 1. Okay, now so put the q1 by t1 value in equation number 1. Okay, so if you put this value, you can get integration of cyclic integration of del q by t, that is equal to q2 by t2 minus q1 q2 dash by t2 dash. Okay, now so here there is one reversible, this is a reversible engine and this is a irreversible engine. Okay, so we know that reversible engine efficiency is greater than irreversible engine efficiency. We proved that in previous lecture. Just we proved that irreversible engine efficiency is always less than reversible engine efficiency. So efficiency is basically known as output by input. Okay, so here reversible cycle efficiency always greater than irreversible cycle efficiency. Okay, so here for reversible cycle, so efficiency, that is output by input. So what is the reversible cycle efficiency? That is W1 by Q1, that is equal to, what is irreversible cycle efficiency? So this is not equal to, greater than W2 by Q1. Okay, so W2 by Q1. So from here you can say that W1 greater than W2. W1 is greater than W2. So from here you can say that W1 is greater than W2. So if W1 is greater than W2, so here this W1 this W1 is greater than W2. So from here you can say that Q2 Q2 is always less than Q2 dash. Okay, Q2 is less than Q2 dash. Okay, so if Q2 is less than Q2 dash, then put this value. So here put this value. Just consider this value. Then as Q2 is less than so here Q2 is greater than, so here Q2 is greater than Q2 dash, sorry, Q2 dash is greater than Q2, so that is why this value will be negative. This value will be negative. So from here you can prove that that is irreversible cycle del q by t, integration of del q by t, that is equal to 0, sorry, that is equal to negative for irreversible process. Okay, so from here the process inequality say that is cyclic integration of del q by t less than 0. If this is less than 0, then it is a possible and irreversible engine. Okay, and the second case is if cyclic integral of del q by t that is equal to 0, it is a possible and reversible engine. And the third case is that if there is a cyclic integral of del q by t greater than 0, then it is an impossible engine. Okay, so remember this data, this is very important. So this is my handwritten notes, you can download it from the description. Like, share and subscribe my YouTube channel. Okay, thank you.